Greetings and welcome. In this session, we will discuss about the construction and working principle of Venturimeter. In last video session, we have discussed about the Bernoullisequation and also discussed in a brief about the applications. So mainly there are three applications of Bernoullisequation. First is a Venturimeter, second is a orifice meter, and third is a pitot tube. In this video session, we are going to discuss about construction and working principle of Venturimeter. So Venturimeter is a device which is used to measure the discharge passing through the pipeline. So here in this image we can see this is an industrial application. This is a large diameter pipe through which fluid is passing. To measure the discharge passing through this pipe fluid is not possible or not appropriate by using conventional method, that is volume per unit time, meter cube per second. So there experimentally this discharge is measured by using Venturimeter. So for that there we can use theoretical discharge formula. So that we are going to see in a further discussion. About the working principle, here if you see, this is a pipe diameter, and in this Venturimeter, this pipe diameter is reduced. So as per the continuity equation, we know that continuity equation means what? Product of area into velocity is remaining constant in a flow for ideal fluid and in case of incompressible fluid. So here, if the diameter is reduced, then area is reduced. Means when the area is changed, then velocity is going to change. So at this section, when the area is reduced as per the continuity equation, velocity is increased. When the velocity is increased means kinetic energy of the fluid is increased. Now we come to the Bernoullis equation. Bernoullis equation is what? Sum of first pressure energy, second kinetic energy, and third datumenergy. So out of that here, as this pipeline is a horizontal, means datum level is a same throughout the journey. So here is what? Two energies. First is pressure energy and kinetic energy. So when there is a change in the kinetic energy due to change in cross-sectional area, then this kinetic energy change is changing the pressure energy. And this change in the pressure makes possible to measure the discharge. That is what working principle of Venturimeter. So that is why here we say that by reducing the cross-sectional area of a flow passage, pressure difference is created, and this pressure difference makes possible determination of discharge through the pipe. Now we will see Venturimeter construction. Here we see the diagram, schematic diagram of Venturimeter. This is a pipe inlet, pipe outlet. In this pipe, this Venturimeter is fitted. Venturimeter consists of mainly three parts. First, converging cone, second, throat, and third, diverging cone. These are also called as convergent section, neck section, and divergent section. Now, as far as dimension of these three parts are concerned, here, if you see this D1 will be pipe diameter, then diameter of throat is taken as a D2, and this D2 is taken in the range of 1/4 to 3/4 diameter of pipe. In general here, D2 is taken, means throat diameter is taken half of pipe diameter. Length of throat is normally taken equal to diameter of throat. Now about the converging cone. In a converging cone, this angle is maintained about 21 degree plus minus 1. While in case of diverging cone, this angle is ranging from 5 to 15 degree. Length of diverging cone is more than converging cone. It is about 7.5 times pipe diameter. Now here in this Venturimeter, to measure the pressure difference, differential manometer is used. So this differential manometer is fitted to this venturimeter and pipe section in a such way that left side limb is fitted on the pipe. We say this as a point or location number 1, while other limb of the U-tube manometer is fitted over the throat section. So between 1 and 2, because of change in the diameter as per discussion of working principle, there change in pressure taking place, and this pressure difference is shown by using this fluid which is present in the manometer. So mostly there are two types of fluids. One is a heavy fluid and another is a light fluid. Heavy fluid mostly is used as a mercury, and light fluid is used as a petrol base, which is light in the nature. So here the level difference is created. So this level difference, that is called as Y. It is shown by Y letter, that is what deflection of manometer fluid. So this is in meter. This Y deflection is in the form of manometric fluid. We have to convert this Y deflection in the form of fluid, in the term of fluid which is passing through this pipe. So for that we use the formula. So when it is called as Venturimeter head, it is denoted by H. So here, as per the two types of fluids what we have discussed, that is for heavy fluid, means in case of mercury, SM means specific gravity of manometric fluid, and SL means specific gravity of liquid passing through the pipe section. So for a heavy fluid means SM greater than SL. H is equal to taken Y into bracket SM by SL minus 1. For light fluid means SM, manometric fluid, specific gravity is less than liquid passing through this pipe. So for this Venturimeter head formula is taken H is equal to Y into 1 minus SM by SL. So by using this formula we calculate the Venturimeter head. This Venturimeter head we use in the calculation of discharge. Now here we will discuss about only the key parameters which are important parameters, that as the diameter of pipe, inlet pipe is a D1, so pipe area will be A1, that is pi by 4 into D1 square. Throat diameter we have taken D2, so throat area will be A2, that is equal to pi by 4 into D2 square. Now theoretical discharge, this is a formula we use. QTH is equal to A1, A2 in these both areas multiplied by square root of 2GH, where H, that is what Venturimeter head, what we have seen in a last slide, divided by inside the square root A1 square minus A2 square. By using this formula we calculate theoretical discharge. Then to find the actual discharge we use the relation between coefficient of discharge. Coefficient of discharge is what? It is a ratio of actual discharge to theoretical discharge. Now this CD experimentally is obtained and it is in the range of 0.96 to 0.98. So by using this CD value we can calculate Q actual discharge by multiplying it to theoretical discharge. So here we have seen in a today's video session the working principle and construction of Venturimeter. Also we have seen some important key parameters to measure the discharge of a fluid passing through the pipeline for industrial application. Let us meet in next video session. Thank you.